So today I'll be discussing about optimizing real-time SLAM performance for autonomous robots with GPU acceleration. So basically, I'll be explaining what is a SLAM, few fundamental principles of how it works, and what is the need of optimizing real-time performance. That means I'm going to reduce the computational requirement for the SLAM. And in the context of robotics, how it can be helpful. That will be my key discussion point for this topic. So those of you who are really working in development of SLAM algorithm for the autonomous mobile robots, or if you are into the AR, VR stuff for the 3D reconstructions, you will find this session very much helpful. Yeah. Thank you. Okay, so this will be the overall outline for this presentation. I'll give a brief introduction of what is a SLAM. Then I'll give you a brief background about what are the different challenges of the SLAM. And then I'll walk you through a different state-of-art SLAM algorithm and why we have chosen one specific algorithm on which we applied the GPU acceleration. I'll provide you at the end experimental result setup and few discussion points so that I can prove my claim. Yeah, so SLAM stands for simultaneous localization and mapping. So essentially, in context of robotics, it provides answer to two questions. Where am I? Which is essentially a localization component of SLAM, which provides robot's position and orientation within the environment. And the second question is, what does the environment look like? So mapping part answers that question. Using the sensors, it generates a surrounding map of a robot. Where it can be used, so I'll give you a simple analogy. In the morning when you started to come to this convention center, first thing that you have done is you have opened your map, then you have clicked the auto detect location because you want to know where you are, and then you have started the navigation. So, in any case of autonomous navigation, the SLAM is the first part of it. You need a mapping, you need a localization. And this always happens simultaneous because you need to know where you are and you need to know what does the environment look like. So applications, again, I've said that it's in robotics, autonomous vehicles, and if you are into AR, VR, that the generation of map could be used as a 3D reconstruction for your AR, VR system.